Well, welcome back, my friends. We're going to examine the methodology for using SPSS to conduct correlational analysis, specifically to obtain the Pearson R correlation coefficient. So just bear with me and we'll get into this. Now, when you go into SPSS and you get through all of the entry stuff, the first place you want to go is to the variable view, and there you want to name your variables, establish whatever you want with the numbers of decimals and so forth. Once you name your variables, you want to put them in. In this, I've entered age and just made up some data called annual income so that we have something that we can use in order to conduct the correlational analysis to get the Pearson R coefficient. It is interesting in this that when you do a correlational analysis and you're looking for Pearson R, the very first thing that you need to do is establish that the data are normally distributed. So the first thing that I did is I went to analyze, I went to descriptive statistics and selected descriptives. Once I select that, I move the variables from the left side over to the right side, and I will hit, at that point, I will hit options. And when I hit options, this comes up. I selected kurtosis, skewness, and kurtosis because that's really what I'm after. I don't need the mean and standard deviation because I can get that otherwise, but it doesn't hurt to have it here. So once I have selected skewness and kurtosis, I tell it to hit this here. I say OK, continue, and hit OK, and it runs the data for me. It tells me that there are 10 of each of them. It tells me what their maximum and minimum, the mean, the standard deviation. I mean, I ask it to give me that because actually if I'm doing an analysis that I'm going to report, I need those data. But what I'm interested in is the skewness and kurtosis so that I can establish that the skewness and the kurtosis scores are between -3 and 3, thus establishing that the data are approximately normally distributed. So I met the protocol requirement to do a Pearson R. These data are approximately normally distributed. Now, if they were not approximately normally distributed, what I would do is use one of the correlation coefficients that does not require normality, that works for non-parametric. Once I have got this in the readout and I have that table, I go back to my data analysis. I go down to correlate, and I select bivariate. Remember, we have bivariate. We're going to correlate one variable against another. So we do that, and when we select bivariate, it takes us to this. We have to isolate the data values, and we have to move them over to be the variables that we're going to work on. You notice by default it goes to the Pearson R, and we're going to select options. Just to let you look at that. There's really, I mean, everything's automatic, so we select continue, we select OK, and when we do that, we come to this value here. Here's the original table that we calculated with the skewness and kurtosis. Here are the descriptive statistics. It gives us, again, the mean and the standard deviation and the number. But what it gives us here is the Pearson coefficient, and the Pearson coefficient is 1.650. So there is a positive correlation, it's 0.650. So there is a positive correlation between the variables of age and annual income. And it is a fairly strong 0.650. I think would be very close, borderline, just barely borderline strong, but that's okay. We now have what we need. So we can report that we met the protocol requirements, the prerequisites. We established that the data were approximately normally distributed. We then ran the data to get the Pearson R, and the Pearson R gave us a R equal to 0.650. We know that in the case where R equals 0.650, that falls into the strong positive correlation. Now, if it had been a negative correlation, it would have given us a negative value there because it gives us the Pearson R. And as we discussed in a previous video, the ranges run from -1 to 1. So well done. Now, I don't want you to panic again. You've got this. Your sharpest attack. You're moving. So now you know how to utilize SPSS to get this done. Good luck. Have fun on your journey.